Hi, everyone. I'm happy to be with you today. Hope you are all well. Welcome to this talk on backend versus frontend in desktop application. My name is Jérôme Blais-Morin. I'm a computer engineer and team manager at NDT Global. We have an interesting topic today for you. We'll look into it in a bit, but just first, let me take just 2 little minutes to talk to you about NDT Global, just so you have some context in about what we do, and maybe why we chose fat client versus thin client and stuff like that. At NDT Global, we develop and operate robots for pipeline inspection. We offer the service to the pipeline inspection of our clients. They are the pipeline owners, and we are technology experts, let's call it like that. Our robots permit to detect cracks, dents, metal loss in their pipelines. I can show you a quick 1-minute video on this, just to put some images on it. Let me switch the screen to this here. I'll do the voiceover, remove the sound. So in a second, you'll see an image of one of our robots that we built. There's various size and shapes, always cylindrical though, because pipelines tend to be cylindricals. The robot would go into the pipeline. It has no engine on it. It's really the medium, so the petroleum, the gas that would push it, and along its course, it will send ultrasonic waves towards the wall of the pipeline. We'll see that in a second. So it shoots an ultrasonic wave. The wave bounces back and come back to either the same sensor or a different one. And with that, we can detect if there's an anomaly in the pipeline. Here we see a crack, so it can detect that. If the wall is thinner than usual because there was some metal loss, we can detect that too, and things like that. So almost always ultrasonic. We have other technology as well, but that's our prior one. I can stop the video already. So that's just to give you a very quick idea of what we do. We have a multidisciplinary team. We have people from software like myself, people from electronic, physics, mechanical engineering, and application engineering. On the software side, we have many aspects, from pipeline inspection to the data analysis at the end to produce the final report to the client. And on my side, my team, as I said, I'm in software. We support the inspection preparation. We build a software to find the optimal robot parts to build the best robot for a given pipeline. So depending on the size and what type of inspection we want to look at, cracks, metal loss, and things like that. If I dare, we do have open positions, so you can have a look at NDT Global in the career section, and it's an interesting place to work in. Okay, so we have an interesting topic today. Let's look at today's agenda for this. Let me go back to the presentation here. Today, I will show you something interesting, and funny enough, it's point number 2 here, not point number 1. Point number 1 is standard way to do WPF. If you Google it, how to do WPF application, that's point number 1. Point number 2 is a slight difference how we do it, and it has some advantage, pretty interesting. So we'll look at that. And I never saw that approach outside of NDT Global along my career. I did WPF in a few places and on the net too. The example we see, our approach here is, well, I never saw it outside of NDT Global, so I think it's a good platform here to share with you and even take questions and comment on it. So we'll have time for questions at the end. Let's dive into it right now. So as I said, first, some theory on regular WPF at first. There are 3 core components in the WPF application. There is the view model, and the model. The first letter here in MVVM pattern. which is the pattern used in WPF. The first letter stands for the model. Then we have the view, and finally the view model. I will go pretty quickly because, as I said, part number 2 is more interesting, but still, let's look at them very quickly. The model, it consists of the data and the business logic. In other pattern like MVC, you have the model too, and it would be the same concept. Typically, that backend code, so the logic of the application. Then you have the view. So it's a pure description of the UI element. We have an example here. In WPF, it's written in XAML code. That's front-end totally. It's would be a bit the equivalent, that's a language abuse, but of HTML in a web application. And finally, the view model. This is, in a way, the model of the view, and that's why it's named like that. It would contain data and some interaction logic for the view. The link between the view and the view model is done via binding. That's a very important concept in the MVVM approach. For example, here, if we have a text box in the view, we see a binding. So the text that it will display is binded to a variable, a property name in an object in the view model. So that's an example for a text box. Here we have a button, and it's binded to a command. So whenever we click the button, there's a command or some code that will be triggered, and that will also be in the view model, and we see its link to the view model via bindings. The view model really exists to support the view. It would not exist if there was no UI, so it is front-end code. I prepared a little demo application. We'll look at the application itself and the code, so it makes things more concrete. Let's look at this right now. Let me open Visual Studio. Well, I'll just launch the application first. Oh, sorry for that. Here, let's go back here. Okay. Here you see that little demo application. It's built on top of our proprietary application framework. We call it AppKit, but every concept that we will see today would apply without this framework, so don't worry about that. In our application at NDT Global, we usually separate them into module. Here, there is 2 separated modules here. The first one at the top, I implemented it with the standard MVVM approach, how I would do it if I would Google how to do WPF application. And the other one is how we do it at NDT Globals with our slightly different approach. Let's look at the first one here. I stayed in my my world of part management. You'll see that. So in the little demo application here, there is a part list, all dummy parts, of course, part 1, 2, 3, 4, 5, etc. You can add more parts. You can remove parts. I need to select one to remove, etc. If you want, you can change the name and the description. You can tell that that's dummy application, of course, but you can add batteries as much as you want. You can reduce them once you reach 0. You cannot remove any more battery. So that's a little demo. Just to spoil you a bit, in the other approach, it's exactly the same same look and feel. Everything does exactly the same thing. Just to show that both approach would result in the same UI, but the code's a bit different. we can have a look at the code in Visual Studio. In the Solution Explorer here, I have some common classes there. We have the two modules, so the standard MVVM1, that's our approach. That's just a home module to all of them. We have a database service, but that's not really important for us today. So let's have a look quickly first, as I said, the standard approach, standard MVVM module, how it's done. I will focus mostly on the view model. The view model has some properties. For example, the robot parts, it's a collection here. That's the part that you would see on the left in the view. And the selected part, so whenever we select a part, this one gets changed to the selected one. And it has, so those are, let's say, everything that is binded. If I look at the view, I open the view in XAML, as I said earlier. Should open in a second. Yep. So the list box here, the list on the left, the source of the items are all the robot parts, and whatever selected item is the selected part. So it is binded to it. But let's close that for the moment. In a view model, we do have things like that, properties that will the model of the view. So those are, it's the data of the view. We have commands as well. I'll just reduce the properties for now. We have commands as well. So whenever I click remove battery, there's a command for that. And if we look at the constructor here of the view model, we see that, okay, it received a database service for all the parts, and it creates all commands. And when we create a command, you just say, whenever you execute, what do you do? The callback is on remove battery. That's code in the view model. And there's also another method that tells you if you can execute this this command or no. So can you remove battery? If I look very quickly, that's a few lines code on remove battery. What does it do? I hit F12 to go that. I'm still in the view model. So, okay, just double checking that there's a selected part, but the real important code is it reduces the battery count. And and the other method that was, can you remove battery? Well, it would check, is there a selected part, and it does its battery count, is it greater than 0? Okay, so that's very, very standard WPF. You have a view model, commands, properties, and the callbacks of those commands. There are some problems with that. And that's next point in this presentation. Let's look at some problems with this approach. It's the standard one. It's not bad at all. It's just there's still some drawback of it. The first problem that I have here is the view model have their own collections and properties. This may not be a problem for your specific application, but in our case, we have various screens and various view model with them, and the user can go from one screen to the other to complete a task, and a bit like in a wizard approach. And sometimes, or with this approach, the information could be not synchronized because every view model has its own set of properties, own set of collection of selected part, some other information that maybe, if we'll talk about reference type versus value type, but some value type. So if you change it in one view model, it does not necessarily change in the other view model. So information between screens, between view model can be not synchronized, or at least you need to make sure to put all the necessary code to make it synchronize. So that's one problem. Problem number 2 here, and I think if you did worked with WPF before, you will agree with me. The view model can end up with having a lot of logic code. And if you are more familiar with the web environment and not desktop application, you may have the same problem. The UI may have too much logic code to your taste, and that can become a problem. Have the little code example here that's come from the demo application. It's not a very complex code here, of course, and it's just a demo, but it permits to make my point. The code here that we saw was in the view model. When we want to know if we can remove a battery, we verify that there's a selected part. So can you remove a battery? We verify that you can, there's a selected part, and then you verify the battery count. And the action to remove it, you just decreases. Okay, so then why is that a problem? So, okay, it's a nice code, you have it. You may ask, why is it a problem that this code be in the view model? And the answer to that is it brings us back to the backend versus front-end separation. The model should contain the business logic and as much as possible, not the UI. And that's not just philosophical. If you have a given backend, you have a UI, maybe you have as well, either now or in the future, you can have another interface to interact with that backend. For example, if you have a beautiful WPF application, you use a standard MVVM approach. At one point, maybe you want to upgrade it to support calls via an embedded web server, and you may know that's possible, right? With .NET Core, you can have an embedded little web server in your application. You'll need some sort of API to make available. Maybe this API in this case would have a method to add or remove batteries. So the code that we have in the view model here, you would need to have the exact same copy in the API, right, to determine if you can add a battery and what do we do when we remove a battery. Of course, here it's super simple code and it's trivial, but if it's a more complex logic, well, then it's even more a problem if you duplicate the code. And of course, you can have a utility class or services and everything for that, but still, there will be some duplication, at least knowing that you must call this service at both places. Even if we don't talk about fancy web server and API, it can be, with this approach, can be tougher to modify the applications. For example, you have implemented a functionality to remove battery here in a view model. If you want to permit to remove batteries in another view model, then again, you'll have to duplicate the code or something like that. But I'll come back to the this example a bit later. And we are now in part number 2. That's our approach to WPF. Before talking about it, or to start talking about it, we need to talk about our backend. And now we are talking about desktop application, right? It's not a web app. In a web application, you have the server and you have the client that runs on the client computer. But in the desktop application, everything runs on the computer of the client itself. So what is our backend in our case? As we saw in the standard approach, we have view models and views. So indeed, we can wonder, that's all front end, what's the back end? Well, for us, well, there will be model class at first that will be part of the backend, although it runs on the same computer. But there's also one class that we will consider backend and everything, and some utility class around it, of course. And that class, that core of the backend, is as well the class that will decide which view to display. In our framework, we have modules, and each modules have a workflow class. That's just its name. It could be a different name, but it could be the backend class or whatever. Workflow mostly because it decides which screen it display. It is really the workflow class for us is the core of our backend. If we look at the code, it looks like that. So that's the workflow class for our part manager module. If I look first at the constructor here, part manager workflow, what does it do? It receives a database service. It keeps it for later here. And after that, first thing, it would create a screen. So it adds the workflow screen to the available screens. It calls set context on it. That's a very important part of what's coming. And then it will subscribe to any event that occur to the screen. That's also very important. I'll come back to that later. Here, of course, we don't see the entire code, but whenever the module is launched, this is a class. This method will be called start workflow. Okay, it starts for loading out parts from the database and would show the first screen of this workflows. So maybe nothing extraordinary so far, but this is the core of our backend, and you'll see its importance in a bit. Let me go to the next slide. In our approach, we do follow MVVM, so we're still, let's say, consistent with that, but we do two things slightly different. It's like an improvement, I would say, on top of default implementation of MVVM. One is we have a context object. We saw it very, very rapidly in the previous slide, but we'll talk about it. So we have a context object, and that will contain the state of, in our case, of the module, can be of the whole application, depending on how you do it, but it holds the state of it. And the second one is that we'll have all the commands handled by the backend instead of in the view model directly, as they do it in the normal view model approach in MVVM. Let's see that in more details. First, important part to support the whole thing is the context object. So in the workflow, this workflow would create a new context object. It creates it just once, never changes, and it will be passed to to the view models. Here it's passed to a screen, we see, but the screen holds the view model, so the screen just passes it over to the view model. In the view, it's a very, very little difference with a normal approach. Instead of just binding to the robot parts property of a view model, we would bind to context, which is held by the view model. So you bind to the context dot robot part. So it's very straightforward here. I didn't show it, but if I just go to the next slide, the context here, part manager context. So for this specific module, we have a context. It holds the properties, right? It holds that was in the view that were in the view model before. So we have robot parts here, the selected part, all the same thing. So that's it for the context. We do have one context that holds the states. We pass it to the view model. So instead of having the view model to hold those properties, hence the state. So let's go now see the second thing that we do. The second thing is we have the backend handle the commands. We can see that directly in Visual Studio. I'll open it. Okay. If I open, I'll just close this one, close that. So now we'll work, we'll look at code in that other module, which is that uses our standard approach, our approach, and not the standard one. If I open the view, so as I said, context dot whatever was written before, and if we look at a command, for example, there's a button. It will still trigger a command in the view model. If I go open the view model now, let's have a look. First, let's in the constructor of the view model here. Okay, one thing before. So in the property, so we got rid of all the properties that were there, selected part, blah, blah, blah. We just have the context. Okay, I don't count this one. We just have the context part, this one. And in the context, we have 12 on it. We saw it does hold those things. Let's go back here. In the constructor of the view model, in the previous approach, we did create the comments a bit like that, but the code that will be executed whenever, for example, this remove battery command is, instead of having a callback inside of the view model, it will just raise an event. Remove battery, we have events here. So it's just an event that somebody can listen to. So it will just invoke the remove battery event. And who listened to that? In the end, if I go, actually the screen listened to it and the screen fires it back. I'll show you that. It's a bit plumbing code, but where's my screens? Screens. So here, a bit cryptic, but the remove battery of the view model is listened by the screen, and the screen also have an event that is also called remove battery. And who listened to this one? It's the workflow. So from the view model with this event, we go to the screen and to the workflow, which is our backend. So whenever we were in the constructor of the workflow, we said we do subscribe to events on the screen. If I have 12 on this, so they just, you can zoom in a bit. So whenever the screen tells us that there was a command triggered, the remove battery command, then we would execute code. But this code is in the workflow, so that's the difference. So instead of having this method in the view model, we have it in the workflow, so in the backend. So we do, that's what I meant by we have the backend handle all the, let's say, the logic, the command itself. If I go back to, I'll just close them. If I go back to the view model, one other thing, the can execute. The way we do it is instead of, again, putting some logic in the view model to determine if the command can be executed, we ask the state to tell us if he's in a good state to permit remove battery. And we said the state is in the context, so the context will tell us. And I can go see the implementation, F12, same code, but in a different place. So the context can tell us if we can remove battery. And something that you may know, in WPF, the can execute is not, that's also very logical. It's not executed every millisecond or whatever. It's not a polling thing. You need to tell the command when you want it to re-verify if it can execute. And so the context needs to tell us when he went from false to true on the can remove battery. So if when it changed state, and this is done by events again. The context has a different set of events, the can actions. So can remove battery change. So whenever the context determine now he can and no longer can, he would fire this event. The way it's done in the context would be a similar way that you would do it in a view model. So if, for example, if the selected part changed, so in the set, you would, we do some plumbing code here, but when the selected part change F12, when we do raise all those events, so then if you change the parts, then maybe it's null now, it's not null anymore, so you need to say I can no longer, or now I can remove batteries. If I go, so it's same code as the standard approach is there, but it's in different places, and in a bit we'll see the advantage of it, of course. If I go just back before to the view model, the one good thing about this approach is the view model gets very thin. If we look at what it contains now, well, we do have events for when the command is executed, we want to tell the backend to do the code. So we have events for that. There's a one-to-one case for the command. So we have here 4 as well commands that can be executed, binded to the view, right? We said we have the context. This is just the way we would decide where the view model would stand in the screen. It was there in the other approach too. And we have the command creation. We have that method to set the context, because the backend would create the context. It would just pass it over to the screen and to the view model. It's set the context. That's, let's say, just some plumbing code. And after setting the context, we subscribe to its event. So for example, whenever the can remove battery change, oops, sorry, that's the unsubscribe. In the subscribe, we would execute, we would tell the command raise can execute change. And that's what actually, what I was talking about. It would reevaluate this method. So that's as well, like in the standard approach. However, in the standard approach, instead of listening to an event of the context, you would look at what's happening in the view model itself. So here it makes a view model pretty thin. That's one of the advantages. But of course, the code is just somewhere else, but there's more advantage to it. We'll see that in a second. If I go back to the presentation, let's have a look at those advantages. Regarding the passing of the context to the view model. First advantage is it avoids duplication of the information, which could lead to the data not being synchronized. So this is the example that I was talking about earlier. So if you have the same data in more than one view, maybe not synchronized, but if you have the context, it's the same context that show those data, that it would be synchronized by default or by definition. Another advantage, it encourages maintaining a very consistent state. So it separates the context contain the states. It's not here and there in various view models. So the context contains the states. In it, if a property changes, then it impacts another property, for example. And here I add just that, to be frank, this consistency is supposed to be done in the view model, as well in the standard approach. But Oftentimes, some people may cut corners if it displays correctly for the UI. They don't completely update the state, but still, it's not a real case, blah, blah, blah. So it's if it's in the context and that separates the concern, there's more chance that you will try to keep a very consistent state. And last but not least, advantage for this one, having a context object, it does permit the backend to know the state. And that's very useful for the other part. If the backend is handling the commands, well, it does need to know the state for sure. Advantages regarding the delegation of handling of commands to the backend. First, important one, there's less logic in the front end. So the opposite of the disadvantage that I was talking about. It's better if the code is in the backend. There, you can have many or different front end for it. Second point here is, and that's pretty important too, or pretty useful, if you can change more easily the application if you do an approach like that. For example, if you have a save functionality in one screen in a view, then if you want to permit the save in another view, well, you just add the command, you fire an event, and the backend would execute the exact same code. And as well, the context will tell you if you can execute depending of if the state is right time to save or not. And the opposite is if you have the code in the save functionality in the view model, then if you want to implement it in the other one, well, then you need to recode, duplicate code, or try to use, well, hopefully try to at least use utility method and try to not duplicate code too much. But still, this one, it's even less duplication. There is, it pretty much covers what I want to talk about our approach. But just before we leave, I just want to talk about two things, the requisite and some specific case on our approach. One requisite to our approach is that the model classes, or whatever hold the data itself, they must be, quote unquote, bindable. What does that mean, bindable? In WPF, the way the UI is told that it needs to refresh to show the new value, it's, again, not a pooling mechanism. It's told that the value has changed. And the way it works is, for example, here, whenever we set the name, here it's called an utility method set property, but that utility method fires a very specific event. It's the property changed event. And if you work with WPF, you do raise that event everywhere when you set something in a view model. But now in our approach, if you don't just show little, let's say, little pieces of information in the view model, but you hold a full context and a full class, then the class must raise the property change event. So you do have that. This needs to be there. Hopefully you have a possibility to change it. If you don't, you would not be able to use this approach. Yeah, that will raise the property change event. And finally, just let's have a quick look at some use case, some variation of this approach. There are cases where this approach works better than others. The case that we've seen today, the value, whenever we change a value in the user type, a new name or whatever, it directly modify the context. And if you have many screens, any other screens would know directly. It's the same context object, so they would be impacted directly. And for this case, our approach works very well because you change the context all the time. And maybe in cases like that, it doesn't mean everything is saved automatically. You can still have a save button in the view, and when you click save, then it persists the thing to the database. So there still can be a confirmation like that. And in our application. That's usually how it works. There's another case though, and that can happen in even, we do have that. If you have dialogues window and that dialog window has a cancel button. In this case, then you can still pass context in to the dialog for any in data, but maybe you don't want to modify the context directly in case the user hit cancel. Well, of course, you don't want any change to take effect. So for that case, maybe you may want to return a result from the dialog window or something like that, or maybe the dialog window changes the context only upon confirmation or OK. So it's just something to keep in mind regarding this approach. And that's it. I think we do have time for questions, so please feel free to ask.
Hello, and yeah, thank you for that. So lots to take in. I think it's an interesting thing because when you are not in an environment like yours, then you actually try to get as much on the view as possible because you're actually executing it in your end user's environment. Whereas like in your case, it's the same thing. So it totally makes sense to actually put more onus on the back end to make sure that the views are as easy to change. And the as you said, like you might have different views, and keeping it in the back end then make sure that in all the views it actually comes in. What I was wondering about, like, what is the size of the applications that you're building that way? Like, what do you see a benefit of actually having smaller applications created with that kind of approach than the one that are more view heavy, or is this something that is actually in that environment not that much of an issue?
Well, first of all, the size is not a lot of an issue, right? We install it on a computer, and when it's installed, then it's there and it sits there, so no problem. But as well, it won't make a big difference on the size because the same code exists. Of course, if you duplicate it, well, you would have some kilobytes additional, but the real benefit is on the maintenance, how you can do maintenance on it more easily, right? You change views, blah, blah, blah.
How often do you have to change the applications that you do? I mean, that's one of the benefits of like not having installed applications, that they're easy to change. But how often do you actually change interfaces accordingly? And where do these use cases come from? From like end users or from your development team as new features?
It's both, right? We have feedback. They'll want the help button in every screen instead of just the end screen. So so that can come from feedback. It can come from us too. We create a new functionality, and let's say part of it was already implemented. It's just a reuse. So it's well, application do change, right? They are not static, so it comes all the time. So it needs to be easily changeable.
And how big your environment? How many applications are you actually maintaining in your team? Is it and across it? This is all Windows machines right now. You have nothing else where you need to actually supply.
Yeah, we have. It's just Windows machines, and we have the luxury of having the people that use our application is our colleagues. It's not external clients, external person. So we know pretty much the machines. It's some Windows 10 coming to Windows 11, and then now I forgot the initial questions. The number of applications. So we have my team has his main application to manage the parts and select the parts. There is two other that are under maintenance, but and in other teams, because there are other teams software, they have maybe 3-4 more applications in total. Yeah.
And how many people working on these applications? What's your team size?
My team size, we are 5 right now, and in the other teams, there are 10 additional people for the other applications. Yeah.
Do you find this approach of architecting the apps is different from somebody who just came from a WPF background that basically has a normal approach to it? Is it something that you had to convince your engineers to take on, or is it something that actually makes sense for them to do? And
well,
how
it's
much
new.
selling do you have to do internally?
No, it's new, but it's truly better. So it's easy to convince. It's just new habit to take. I had to to learn it myself, right? I was coding in WPF before coming to NDT Global, and I was using the standard approach. And I came to NDT Global, and I received that. It is better. There's some plumbing code, firing the event, getting used to the code not being just there in the view model, but in the end, there's true benefits. So I think it's easy to be convinced of it. Yeah.
Cool. Well, there's no questions that came in from people out there. You already said you're hiring, you're actually looking for more people, and well, the company is not necessarily your team. And we also had another video with a colleague of yours last week who actually talked about like what is it like to be an NDT Global as a data scientist in that area. And I find that so fascinating. Like if you talk to people about like you write code, and people are like, okay, you make websites or you do that. And you're like, no, we're making robots that run underwater pipes and check them out. This is a very, very specific use case, but it feels kind of cool and science fiction-y.
Yeah.
What made you choose to go to NDT Global? Like, is it that? Is it just like a challenge that you hadn't thought of before?
Well, I've been always working in a bit techie company. When I arrived in Quebec City, before working for NDT Global, I worked for another sub company of the bigger Previan group. It's based in Quebec City. It's called Edify Technology. It's also in the field of, it's called non-destructive testing. So we do tests. We verify for NDT Global. We verify, right, if there's any cracks. So we do the testing on the pipeline, but it's non-destructive because we don't cut the pipeline to determine if there was a crack. So and in this field at Edify Technology, they don't inspect pipeline. They do and they don't also have the staff that does the inspection. They sell equipment, so equipment that are usually smaller. You would hold the probe in your hand, and you would go through a surface and determine if there's crack, maybe under even the paint or other material, using usually eddy currents and not ultrasonic, but they have some ultrasonic too. So I went there. It's a techie company. I like those. That was, I think, one of the reasons why I went for them. And it's a good
Cool.
working environment. Yeah.
Excellent. And there's a lot of remote work going on, and people are spread around the globe as well, which I love to hear because a lot of companies are trying to get people in one location again. So
Yeah.
it seems like that's still an option for you. So that's pretty nice to have.
Mm-hmm. Yeah, it's a bit of a hybrid mode now, and we do have offices all around the world. I'm in Quebec. There's a big office for software in Germany, Studency, and we have colleague in Houston as well. That's let's say our main offices. Yeah.
That's why the oil pipeline starts and then goes underwater, and then you have to go from there to the other office.
Mm.
Okay. Well, thank you very much. This was Jérôme Blais-Morin from from NDT Global, and he talked to us about WPF applications and the approach that they do inside the company. That's kind of different from what you normally do with WPF, but seems to be an interesting approach. Are you going to write something up about this where people can read that up, or is it more or less like watch the video and get some feedback that way? Is there any way we can look at the model that you do here?
Maybe I can think about it. First, look at the video. I'll see if there's any way I can share same info in a different format.
Okay. Well, thank you very much. Then I say goodbye to Canada, and we are going back to our normal day-to-day job now. And that was the WeAreDevelopers Live of today. Thanks again.